enough that you hear me and see the board okay? All right, guys, here we go. So we are working in section 6.6 still with these rational, which is just a fancy word for fractional exponents. So on Monday, we saw how to convert a fractional exponent into that root n power, and that's how we can evaluate and simplify these fractional rational exponents. Today, all you have to do is be able to simplify an expression that has rational exponents, which, guys, just basically means you have to use your exponent rules, but now your exponents are fractions. So remember, there were rules that told us to add our exponents, there were rules that told us to subtract our exponents, and then there were rules that told us to multiply our exponents. Except now you're going to have to do all those rules, but your exponents will be fractions. So you have to add fractions, you have to subtract fractions, and you have to multiply fractions. So it's still pretty basic. It's just we keep having to work with fractions. All right, so guys, just to review though, if you do have a fractional rational exponent, like a to the m over n, you can't evaluate that until you convert it to its radical form. So just remember, a to the m over n power becomes the nth root of a to the m. That's how we convert a fractional exponent into its power and root. Now, guys, technically this one is telling you to do the power first and then the root second. But remember, you can also write it like this, where it's the nth root of a, all raised to the power of m. In that regard, you'd be doing the root first and the power second. But both of them are equivalent and get you the exact same answer. In a simplifying situation, guys, I'm a fan of doing the root first and the power second. I just think it makes the problem easier. All right, so guys, here we go. Now, we're not going to have to convert today. We just have to be able to simplify the expression down to one base and one exponent. So we have to use our exponent rules. So let's review. Exponent rule number 1 first. When you are multiplying the same base, what do you do with your exponents? So guys, if we had x to the third times x to the fourth, do you remember what you do with your exponents in a multiplying situation when the base is both x? You would add them. This is an adding situation. So I'm going to do one example without fractions, and then we'll do the ones with fractions. So again, if we had x to the third times x to the fourth, how many times do you end up multiplying x by itself? That would be x to the 3 plus 4. We add our exponents. So in this case, it's x to the 7. You would multiply x by itself 3 times here, multiply x by itself 4 times there. When you multiply that together, you will have multiplied x by itself a total of 7 times. All right, so guys, you have to be able to do this problem, but now your exponents are going to be fractions. So let's say you had x to the 1/2 power times x to the 3/2 power. How do we simplify that? Well, in a multiplying situation, when the base is the same, you add your exponents. So guys, this is going to become x to the 1/2 plus 3/2 power. Just add your exponents to create your new exponent. Well, guys, the one thing you have to understand about adding fractions is you have to have a common denominator. So lucky for us, this one already did. They both have a denominator of 2, so you really just add the tops and keep your denominator the same. So this will become x to the 1 plus 3 is 4 over a common denominator of 2. And then just see if you can simplify your fraction. 4 over 2, guys, that's a winner. That's 2. So this actually becomes x squared, and your answer isn't even a fractional or rational exponent anymore. So again, it's going to be pretty basic. It's just you have to work with fractions, and I know a lot of you don't like fractions. All right, let's look at the next one. Let's say you had x to the 3/5 power times x to the 1/4. Well, that would become x to the, add your exponents, 3/5 plus 1/4. So the answer to this is going to be whatever we get when we add our fractions together. So let's go off to the side and add our fractions together. 3/5 plus 1/4. Guys, you have to find a common denominator. You have to make them equal parts. So what number can both 5 and 4 become through multiplication? I think the smallest one is 20, right? So you would multiply this by 4 to become 20, which means you have to multiply the numerator as well. So that becomes 12/20. Plus, what do you have to multiply this by to become 20? 5 and 5. So now you would get 5/20. So now 12/20 plus 5/20, add the tops, is 17/20. And that's your new exponent. So this becomes x to the 17 over 20 power. All right, and again, the fraction doesn't simplify, so as weird as that would look, that'd be the 20th root of x to the 17th. Hey, they didn't ask us to do anything, but that's the exponent we get. All right, look at this one. Now you have to take x and times it with x to the 1/7. So in order to do this, you have to add the exponents. Guys, what exponent is assumed to be on just x? It has an exponent or a power of 1. All right, so now this is going to become x to the whatever 1 plus 1/7 is. So let's go off to the side and add 1 and 1/7. All right, how do I make 1 a fraction? Throw it over 1, and now you have to find a common denominator between 1 and 7. What number can 1 and 7 both become? Well, 7, and 7's already 7. So we only have to change this fraction. So times top and bottom by 7, and you get 7/7, which is 1, plus 1/7. And now we have 7 plus 1 on top is 8 over a common denominator of 7. So we get 8/7. So this is going to be x to the 8 over 7. So it is. It's simple, guys, but you got to be able to add and subtract fractions. All right. Now, I did the next example because I'm pretty sure this is how your homework, the directions on your homework are going to look. So let's just see one written this way. So your homework was going to say, evaluate the left side to find the value of a in simplest form. So guys, the left side is a mathematical expression that you're going to have to simplify, and it equals x to the a. So once you get this down to x to some power equals x to the a, then all a is going to do is equal the exponent that you got. So we just have to simplify this side down to 1 base and 1 exponent. So let's do this. I'm going to do x to the 2/3 times x to the 4th. I'm going to add my exponents. That's going to become x to the 2/3 plus 4. So let's go off to the side and let's add them together. All right, I'm going to make 4 a fraction by throwing it over 1. Now let's get a common denominator. What number can 3 and 1 both become? 3. So I only have to change this one. So it becomes 2/3 plus 12/3. Add my numerators, and I'm going to get 14/3. So this is going to become x to the 14/3. And guys, that is what equals x to the a. So if x to this power equals x to the a, what does a have to be? He's got to be that exponent. So a has to be 14/3. So this is how I believe some of your homework problems are going to be worded, just so you see that. It's still do the problems, except instead of this entire expression being the answer, really just the exponent is the answer. You don't have to put the x to that power, all right? All right, let's do rule number 2. Everybody good here so far? We're all right? At home, thumbs up, we're okay? Okay, all right, here we go. Exponent rule number 2. Now when it's a division problem, if you are dividing and it's the same base, so like x to the 5th divided by x squared, same base, what do you do with your exponents in a division problem? Well, I hope you guys remember, this is when you subtract them. Take the big exponent, subtract the little exponent, and put it back where the bigger exponent was. Now, I don't want to create a negative exponent because I know I'm not allowed to leave negative exponents in my answer. That's why I always remind myself to take the big exponent and subtract the small one. So my answer will always be a positive exponent, and then I'll just put it back on top or bottom, depending on where that bigger exponent was. All right, so guys, remember, when we had x to the 5th, I'm going to do a couple without fractions first just to get the feel for it. X to the 5th divided by x squared, 5 was the bigger exponent. So we would take 5, we would subtract 2, and put it back on the top. So really, this would become x to the 5 minus 2 back on the top. And then it became x to the 3rd. Okay? Well, what if the bigger exponent wasn't on top? What if you had x to the 4th divided by x to the 10th? Now 10 is the bigger exponent. So I'm definitely going to put it back on the bottom and subtract my exponents, which would be 10 minus 4. And now since my numerator is empty, I have to put a 1 to placehold. So then it becomes 1 over x to the 6. So if your bigger exponent is on bottom, your answer has to go back to the bottom. All right, let's do it with some fractions now. If you had x to the 7 halves divided by x to the 1 half, well, guys, you do have to know which fraction is bigger. I hope you realize that 1 out of 2, that's a decimal. It's 0.5. It's somewhere between 0 and 1. If you had 7 out of 2, guys, you have more than 1. You have more than 2 out of 2 pieces. You have 7 out of 2 pieces. So definitely 7 halves is the bigger fraction. However, just to give you guys a trick, I know they teach this in elementary school, but I don't know how long it's been since you've seen it. If you ever want to know who the bigger fraction is, 7 halves compared to 1 half. Do you guys know the butterfly trick? You cross multiply. 7 times 2 is 14. 2 times 1 is 2. Who's the bigger number, 14 or 2? 14. So since 14's on this side, that's the one you get. That's the bigger fraction. All right, so we know 7 halves is bigger. So we know it's going to go back to the top, and it's going to become x to the whatever 7 halves minus 1 half is, and it's back on the top. Well, guys, lucky for us, they already have a common denominator. So 7 minus 1 is 6. So this becomes x to the 6 over 2. And then always reduce your fraction if you can. This becomes x to the third. Okay? All right, look at the next one. If you had x to the 1/3 divided by x to the 3/4. Well, guys, who's your bigger exponent? Would you rather 1 out of 3 pieces? Think about how big that would be. Or would you rather 3 out of 4 pieces? Now, this can be hard because you've cut one shape or one object into 3 parts and the other one into 4 parts. So to kind of see, well, which one's bigger? So again, if you're not sure, do your little trick. 1/3 compared to 3/4. Cross multiply, you get 9. Cross multiply, you get 4. 9's the bigger number, and he's above this fraction. So 3/4 is bigger. So now it's going back to the bottom. So this is going to become x to the whatever 3/4 minus 1/3 is. And since my numerator is empty, it'll be 1 over that. Well, guys, let's go off to the side and let's subtract 3/4 and 1/3. I'm going to go down here. All right, I need a common denominator. What number can 4 and 3 both become? Well, guys, there's a couple numbers they can both become. I go for the smallest one, and I'm pretty sure it's 12. So I'm going to multiply this by 3, and I'm going to get 9 out of 12. Minus, I'm going to multiply this by 4, and I'm going to get 4 out of 12. And then 9 minus 4 is 5 over a common denominator of 12. So this is going to become 1 over x to the 5/12. And you're done. Okay? Everybody good? All right, so again, I don't know if I have to do it, but right now, these problems, this is your answer, the expression, x to the 3rd. This is your answer, 1 over x to the 6th. This is your answer, 1 over x to the 5/12. When you do a problem like this, like the delta math is going to do it, again, in this case, only the a will be your answer, only the exponent. So let's see if we can do this real quick, because the last rule is really quick. All right, so again, if they want to know what's x squared divided by x to the 5/6, well, guys, who's the bigger exponent? 2, which is a whole number bigger than 1, or 5 out of 6. Guys, if you only have 5 out of 6 pieces, you don't even have a whole part. So 2 has to be the bigger number. He's bigger than 1. All right, so we know the bigger exponent is on top. So this is going to become x to the 2 minus 5/6 on the top, right? I'm not even going to put the equals x over a yet. Let's simplify this down. So guys, let's go off to the side. Let's figure out what 2 minus 5/6 is. Put it over 1. What's the common denominator between 1 and 6? 6. So I only have to change this fraction. And I'm going to get 12 over 6 minus 5 over 6. And then 12 minus 5 on top is 7. And it's over a common denominator of 6. So guys, this is going to become x to the 6th power, and it's back on the top, and that's what equals x to the a. So now, in order to make this statement true, what does a need to be? Well, if x to this power equals x to the a needs to be an exponent of 7/6. So now your answer is just the exponent 7/6. Everybody see the difference? Go ahead, Keith.
Well, we're putting in the graph and showing.
I would see, I'm a feeling they're going to put a equals in front of the answer box, and then you're just going to fill in 7/6. Yep. Okay? All right, last rule. Rule number 3. This is the best rule for fractions, especially. So guys, if you remember, there really are only 3 operations that you do with exponents. You add them, you subtract them, or you multiply them. The 4th and the 5th exponent rules were just your fix-it rules, how to make a negative exponent positive, and then anything raised to the power of 0. So this is our last rule, and the only other thing we do with exponents is multiply them. So when one exponent is raised to another exponent, this is the power-to-power rule, this is where you want to multiply your exponents. And guys, when it comes to doing stuff with fractions, adding and subtracting, you got to have that darn common denominator. Multiplying fractions is the best thing they can ask you to do. You don't have to have a common denominator, and all you have to do to multiply fractions is multiply your top with your top and your bottom with your bottom. Just go straight across. It's so easy. All right, here we go. So let's do one without fractions first. So if I had x to the 3rd, something that already has an exponent, and I raise it to another power of 5, that's x to the 3rd times itself 5 times, guys. So the quickest way to get to that answer is to multiply your exponents together. So this becomes x to the 3 times 5. And what's 3 times 5? 15. So that's x to the 15th power. Nice, easy, and quick. Okay, so if I had x to the 1/5, something that already had an exponent, and I raise it to another power of 2/3, guys, this is where you multiply your exponents. This is going to become x to the whatever 1/5 times 2/3 is. And guys, this is the best. You don't got to get anything in common. Multiply straight across on top and bottom. This is going to become x to the 1 times 2 is 2, over 5 times 3 is 15, and then you look to reduce. But 2 over 15 doesn't reduce, so you're done. That's x to the 2/15 power. Just straight across. All right, if I had x to the 4th and I raise it to a power of 1/7, I have to multiply my exponents. So this is going to become x to the 4. But guys, do yourself a favor. How do you make 4 a fraction? Throw it over 1. Give yourself a top and a bottom to line up with the other fraction. Times 1/7. Otherwise, I find when students don't make 4 a fraction, they end up timesing the 4 with the 1 and the 4 with the 7. And you can't do that because 4 is not on bottom. So you definitely can't multiply them with the 7. So then you're just going to get x to the 4 times 1 over 7 times 1. 4/7 power. Always make it a fraction with a fraction. Don't leave it as a whole number times a fraction. Give yourself a top and a bottom and a bottom. All right, last one. This is how your homework could look. Evaluate the left side to find the value of a in simplest form. Guys, if I had x squared raised to a power of 5/6, this is going to become x to the multiply your exponents. 2 times 5/6. Make 2 a fraction. That way you won't make any silly mistakes. So then you get x to the 2 times 5 is 10 over 1 times 6 is 6. But guys, they did ask for a to be in simplest form. If your fraction reduces, reduce it. 2 divides evenly into both, so that becomes x to the 5/3. So now it's x to the 5/3 who equals x to the a. So who does a need to be to make these equivalent, to make this a true statement? A needs to be 5/3. So just the exponent is your answer. All right, are you guys okay? So guys, as much as I know like students like, oh, fractions and exponents, this is actually not a terrible section. Yes, on Monday, we did the converting between radicals and powers and roots, not too bad. Now you're just adding and subtracting fractions. So the problems, they're not complicated in that there are a ton of steps, all right? And that's it. So what I'm gonna do, guys, I know it's June. I know we're trying to get to the finish line here, and we are almost there. I'm not assigning you homework tonight. I'm going to let you do it in class tomorrow as your assignment. However, I am going to quiz you on Friday. So if you're struggling on tomorrow's homework, you're going to have to reach out to me and let me know and let you help you. All right. Otherwise, you're going to work on your homework tomorrow, and then I'm going to quiz you on 6-6, just these 2 things about fractional exponents on Friday. And then, guys, next week, I'm going to do section 6-7, and then we're done. On Friday, I'm going to end there with a 6-7 quiz. That's it. One more section to go. Everybody good? Okay. I don't mean to rush you, but guys, we're racing to the finish line right now. All right. If you don't have any questions and I say your name, you're going to be good to go. I just want to double check your attendance.